Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Hello, my friend. Here's the deal. Had to send this to Galaxy Radio. Repair to be fixed. Just unboxed it on my Dozy. It does 900 watts. On my LA 900 does a KW. Question mark. What he's saying is, this thing does 1,000 watts. My LA 900, which is a 1x4, does 1,000 watts. Why this no do more? Okay, that's what he's saying here. Both a Dozy and my MFJ 870, which is the big windowed MFJ, which is arguably the most inaccurate watt meter they've ever made, out of all the totally inaccurate watt meters they make. Please convert to Class C, power wire upgrade, replace these BS DEIs with HGs. Just do your thing. Fan, run full time, make it. Build it as bulletproof as I can. Well, if anybody could afford that, I would put Toshibas in it. Okay, so our mission here today is to polish a dirty poop, which we can do. We have been known to do this in the past. We have gifted in this department. So it looks like we got stock power wires coming out the back of the butts holes on the amplifier. And we'll see what we got when we get on the inside here in just a second. Once again, the DEI transistors and the PP100s were an earlier iteration, also produced by HG. Just not with the magic schmoo they have in them today. Literally. Ooh, heatsink's clean. Fans are clean. Low noise, long life. The Nigili Fan Company. Okay, whatever. Works. Come to daddy. Got all screws, Ready? Set. Oh, okay, nope. There we go. All right. D08. DEI 2879 19D08. I sure wish we could get the mystical code out of North with the iteration, generation, lot numbers. Yeah. Okay, so this is a later model where they deleted the fuses. Fuse holder's gone. So power wire upgrade, we're going to eliminate this completely. Somebody's already converted it over for us for the fan to run full time. See that here. We'll fix this and clean this up a little bit. And he wants to do a transistor swap. Okay, well, don't have to ask me twice. Let's do it. Ask this probably 3 times a week, every week. And so while I've got this pretty much virginal, pristine amplifier here to demonstrate to you how to do it. This is how you convert your Texas Star Sweet 16 to operate in Class C. If we zoom in here a little bit, this is the side that is opposite from the coax connectors. Here's the front input transformer. I have to describe this all the time. It drives me nuts. If you want this to operate in Class C, you simply unsolder this connector here, this little wire pin here, and move it over to this trace. This trace is ground. You're going to do the same thing here. Very carefully unsolder this ferrite bead with a wire going down the middle of it, and you're going to solder it to this trace. You do the same thing on this board right here. You unsolder it, move it to this trace. Same thing on this board. You're going to unsolder it directly here and solder it to this trace. Converted for Class C. That simple. Okay, so we got the new HG transistors in and it's converted to Class C. Transistors in, converted to Class C. Transistors in, converted to Class C. And transistors in, converted to Class C. So now let's make it pretty. I should give her a bath. Let's take the old nasty flux that's all over this thing and let's make it go away. Make it look all pretty and new. I like doing this on most repairs. It's twofold. It makes it look pretty, but in the same breath it also allows me to make sure that there are no little flicks of solder or shmoo anywhere where they shouldn't be. Guarantee I don't have a short. Usually make things work better. What I am going to do, and I insist I am going to do this, is we're going to get rid of this relay right here. And we're going to go to an ice cube style relay, what everybody refers to as ice cube. A little bit heavier duty relay for the bias. I've had problems with these not holding up and lasting. So I'll make sure to clean around this really good. I mean, what's a little rubbing alcohol amongst friends? I mean, seriously. Allows everybody to sleep better at night, in my opinion. Okay, let's drain it. So these solid state relays have got like a 50-50 chance of working. So what I like to do is put a little 10 ampere in there, because really all this transistor is doing is operating this relay. This relay is in turn running this bigger relay. Now it would save them a bunch of work if they would just put a piece of double-sided stick tape across the back of this relay. What happens is the amp gets hot over its use in time. The heat transfers to the coil and kills the coil in the relay. We've seen it over and over and over again. So, I mean, if they would just put a little tab of double-sided stick tape, that stick tape's all full of air. That foam is basically little encapsulated bags of air. And air makes a great insulator. At least for direct heat transfer. I think we've seen this demonstrated over and over and over again. I used to not believe in it until I started building amplifiers like this. And I was using hot glue and all kinds of flexible rubber-based epoxies and stuff to hold the relay down, because I always heard when I was starting out, oh man, That double-sided stick tape's it's mud duck shit. No real builder uses that. I use it almost in every amp now because it allows us to insulate that relay from having the direct heat transfer into the coil of the motor on the relay. Double-sided stick tape doesn't really hold it in place. It's more or less the parts that surround it that hold the relay down. Okay, like in this situation we use solid wire to hook it up to the board. The double-sided stick tape's there to help protect the relay from the heat environment that it's operating in. This has got a spring, a mechanical spring in it. So its reset function isn't driven by a magnet, unlike some other stuff we know. This will run good for about maybe 4 or 5 years, maybe 6, 7 years, maybe. There's amps out there that have been running a lot longer with it, but that was back when those relays were made in America. Okay. You got to remember, each country's got its own standard of production. And we're not going to lie to each other and sit here and tell each other, oh, no, the Chinese components are always just as the highest quality, and they're the same standard and quality of American components. Man, that's bullshit, and you and I both know it. Now, don't get me wrong, there are like whole city blocks in China where they'll have 10 factories on the same street. And we'll say at factory number 1, they make parts for factories 1 through 9, let's say. Okay. In factories 1 through 9, they have different layers of quality component as you go down the street that they're manufacturing for consumption. There are some higher standard components, but gotta remember, in the American market, usually the guy will purchase the cheapest thing to be able to get the job done. So I've just learned now over time, and I'm going to start doing this more and more and more and more because I've seen too many of these little black relays up and croak. I mean, this is a Tamakawaka Anawanas, who gives a crap, relay. Who knows what standard that's built to? I can physically see the parts in this one, and it's got a spring return. So therefore I know it's going to actually do the job. And all it's doing is switching 12 volt current from here to here, which also in turn powers the bias. But then you'll see that there's this wire that comes off and it feeds the big relay. And when did Texas Star quit using a 6 amp relay here, or 6 amp diode? It doesn't really matter, but. And you'll notice there's a capacitor, resistor, isolation, and then another reference resistor. But it doesn't matter, we got this tied to ground. So the bias is not actually doing anything. There's no circuitry for it to be able to find ground ultimately back here at the end source. So all of these other components are now moot, including these. So this is what it is. We're going to throw the flybacks in it, and then we're going to do the power wire upgrade. It's always amazed me that, you know, you go from your alternator, which is like wire this big, then you run that back to your battery. It's usually a wire about this big. Then you run to your amplifier, which is usually a wire like this big. Then we go and get the wire inside the amplifier, it's like this big. And then we get it down to the transistors, and it's this big. And this represents hundreds upon hundreds of amps worth of current. It just blows my mind. Of course, in the beginning when I first started, I thought that this was the way to go. Would be to run a big piece of wire like this. And yeah, this is the wire that's in my truck now. Like this into the amp, and that would be the most efficient thing. It's really not. It looks pretty, but it's not 1,000% necessary. This is a big help. The wire gauge that we're putting in here is almost twice the size of what was in here stock. The biggest thing with the Texas Stars was to get rid of the gosh darn fuse holders. Those things are just, you'd sit there and you could run them. I'd run them with a FLIR. When I first got a FLIR, that's when my eyes were like opened. The amount of current that gets lost back here on the old Texas Stars. Those fuse holders would just get so hot. So, I mean, like silly hot. I'm like, hey, if I bypass this, and I bypassed all of them, and power level went up. Put out more power, went, oh. Okay, so here's where we're at. Power wires are in, the big 4 gauge is in. Got my distribution wires all cut and figured out what I wanted to do here. Upgraded our fan wire to one continuous piece instead of, oh, what would this be? This was 22 gauge, and we upgraded to 16. So our fan wires are going through a piece of 22 gauge and then going to even smaller non-Teflon based wire. 1, we got rid of the cut. 2, we went to a bigger wire. 3, we went to Teflon, so I don't have to worry about anything melting and causing us problems. When you do the fan delete, by the way, you guys, when you do the thermal fan delete, when you bypass this and make the fan run off the on-off switch, the fan is on its own 3 amp fuse, which we've deleted. It went from here to here. There would be another fuse holder. The amp itself runs on a 3 amp fuse, because the bias circuit, remember, also runs off of here as well. So if we were trying to do, and this fuse is actually important. I delete it in some boxes. When they come in stock, I try to leave it in there. It's very handy to have, especially if you have your switch in the on position and for some reason it gets unplugged, the fan gets unplugged. This can short over here, and that back feeds up, and instead of wiping out one of these traces, it'll wipe out the fuse. Amp's not damaged in any way, but the fuse will pop. Well, if we don't change this out to at least a 10 amp fuse, remember the fans are on their own 3 amp fuse, the amplifier uses 3 amps of its own, that's 6 amps. So they don't make a 6 amp fuse, they make a 5 amp fuse. Now, as soon as I say that, somebody's out there and they're gonna find a 6 amp fuse. Doesn't matter to me. 10 amp is perfect. Put a 10 amper in there. For some reason a short comes along, causes a problem, boop, pops a fuse. End of conversation. It also helps protect the on-off circuit just in case the remote jack gets disconnected. Saying. It's there for a reason. So we went ahead and put a grommet in the back. We went ahead and put inserts in here to block up these stock holes. And then we put an insert here in this, there's a little small remote jack kind of port plug here. I don't know what it was ever intended for, but went ahead and slapped another plug in that, so it'd be all nice and clean and smooth looking and professional on the back. That's what we're shooting after anyhow. And yeah, about the only thing left to do is drop the positive wires from the bus here out to the different transformers, and then run it and see what we get out of it for performance. I'm sure we'll see a little bit more improvement out of this amplifier as far as power output goes. Do keep in mind, Mr. Customer, he says in his notes, BBI, hello my friend. And he makes a reference to his LA900. Remember, the LA900's got a driver in it. Okay, so the LA900's a 30 watt, maybe 40 watt max drive going into it. This has no driver. So if you take like a 1-pill or a modulator or something, drive it into this, you're gonna see a whole lot more power output. Mr. R, by the time it's said and done, this thing will be as efficient as we can make it, and pretty much as bulletproof as we can get. So changing this out helps a bunch. Putting it on a little piece of double-sided stick tape to help insulate it, that's really your best bet. Now all this does is drive this relay. It doesn't even switch the bias on and off, because like I said, we bypass the bias. So on that note, I'm gonna go see what my dog's doing. Probably take him to the dog park and go let him run. It's a beautiful day out, and I'm not spending all day locked up in this shop. If you gentlemen had any clue how long this takes to do, to hand tie each one of these, I understand why the industry as a whole went to zip ties. It is a chore. But all the power wire is in. Everything's where it needs to be. Oh, must have bumped that one when I was tying it. No, I need you straight up and down, little girl. There you go. And no, you can't lay on that. There you go. Okay. So the only thing I got left I need to do now is switch back over to the Anderson clip end. So let's take the walk of shame over here to the Anderson clip pile, which I should have a couple more of these left. Ooh. I got one left, two left. Sheesh. I sure seem like I go through a lot of these, you know? Damn. This is technically just a hair too small for this thing, but they work well. It's Sunday, by the way, you guys. I'm out here working on my single day off. I'm trying. I'm trying. As soon as I get done with this, I gotta go jump onto a 10 pill. Nah. It's all good. It's all good. Let me drill these out, hydraulically crimp, solder, heat shrink, and then we'll put those on. So, see you in about 45 minutes to an hour. Okay, so we're here. First couple times you key this, after redoing all the transistors and changing everything around, is usually your most delicate time. That's when shit's either going to go sideways on you or it's going to go well. And your output combiner, final output combiner resistor, tells you the whole story every single time. So let's go over here and let's take a look at the spectrum analyzer first. So we got a pretty big swath of the universe we're looking at there. 0 to about 250, 264 something megahertz, whatever. So that's just the radio at 01212 all by itself. Here's the amplifier in play. Hello, 1212, 121212 at 01212. So 0 harmonics coming out of it. Let's go over here and let's take a look at the watt meters now. So that's a 1,000 watt slug here in PEP, 1,000 in average, and 5 watt slug in reverse, back from the Bird 10,000 watt dummy load. Hello, audio. It's a hot one. Hello, audio. Okay, now to be fair, let's shut the amp off and let me show you drive power. Hello, audio. Whole whopping 25 watts. So 25 watts in is getting us 900 plus out. Hello, almost pure 1,000 out. And let's see where the rubber meets the road here. So here, this is my finger, is our final combiner. And as you can see, it is 73 degrees. So I shaved that picture, and we'll throw that in the video somewhere along in this section here. So, hello, 1 2 1 2 1 2 1 2. And as we can clearly see, the lines of the, not the lines, but the wire that's covering the ferrite here is actually doing the combining of the RF is getting hotter than the resistors. So that tells me everything in this thing is in balance and it's happy. We're seeing good output power, no harmonics, balanced. Hello, 1 2. Now we'll scan up here. We're going to look at this slug. Now there's a 5 watt slug between the 2950 that I'm using as the driver. Hello, 1 2. Hello, 1 2. Which that is remarkably good compared to what I have seen in the past as far as reflect numbers go. I feel very happy if I can see 800-ish with 20 watts of drive out of a Sweet 16. The fact that we're seeing more than that, makes me relatively peaceful in my mind and happy. So let's go ahead, we'll hop off the 2950 and let's jump over to the Derail Striker 955 El Black Coax. Now this radio is a little bit picky on what it wants to see. Just grabbed a microphone for that. Of course, we knew that was going to disappear off the scale. At 0121212. Let's go up here. So we're looking in this corner. It's a 5-watt slug and reverse between the Striker 955 at 012121212. Nice low input SWR. And now let's come back over here. At 012. Okay. Normally I'm happy if I see about 1400 out of this. Hello, audio. 14 on the button. Okay. Let's see. This hash mark here is 1012.14. Hello, audio. 12121212. Back to the spectrum analyzer. Hello, 121212. A little bit of dirt. But after my year worth of working with this radio, I know that those little tiny side spur harmonics are the radio and the loading of the radio. So it's no big deal. Okay. Let's change radios once again. Let's go over to the Striker 490. Now we're going to hit this with some juice. Blue coax. So, all right, let's turn this off for a second. Hello, 12. Okay, so we're juicing here a little bit. We're on 15 volts. Let's go back down to 1x. Hello, 12. Hello, 12. Putting about 180 into this, which is just about as max as we want to drive it with. So now we're back on 2x again. Hello, audio. Hello, audio. 1555, somewhere in there. Hello, 1212. Hello, 121212. So even underneath full drive, we're going to go up here now. This is a 5-watt slug. It sits between the 490 right here and the Striker. Hello, 12. Hello, 12. Hello, 12. Once again. Hello, 1212. Hello, 12. I like to think of it as percentages of signal on frequency. 95%. 98% is on the frequency we want. So this thing is working titties. All right, so let's disconnect all of this stuff and shut this down. Let's go ahead and unplug this connector. Fire up the FLIR one more time here. Now I'm going to put all the tins on it and stuff before we go any further. So all that operation and the heat sink is at 80. 86, 87. The hottest thing in here is going to, of course, be the bias resistors, which is 122. Box is running ice cold. Okay, let's put the tins on it and let's check our fans and make sure we've got functionality there. So this is one of the new fan kits. Went ahead and added a label to the side of it. The texture of the cabinet's changed. They're no longer doing the vinyl coat. This is actually a paint that's on here. This is the first time I've ever seen this. So that's new. And let's see, Fanzos go there. Like I said, I put a label on the outside, but the texture of this tin is way different than what I'm used to seeing. And believe me, these old eyes have seen a couple Texas Star tins in their day. The downside to the new fans is they don't move nearly as much air. They're using thinner fans that are, well, let's face it, cheaper. And they just don't move the quantity of air they used to. Still enough to get the job done, but it's not the same. The legs are thinner too. The width of them, but the gauge of the metal is actually thinner as well. It's different. It's just different. Still holds the amp up just fine though. Amp off. Amp on. Everything's turning. Much slower fans. But still plenty of air movement. And I mean plenty of air movement. As you can see. Now guys, I gotta apologize to you. Normally I'm really upbeat and cheery, and I've got really 10 million sarcastic things I gotta say, and I'm just tired, man. I'm just tired in a different place inside my mind and my brain. Really wanted to get this done this weekend, and I'm glad I actually made it here. This is one of my goals. Done. Fully upgraded, modified. If you take it easy on this and just hit this with a striker or something, it'll last you forever. Forever. Ask my buddy Rodan. Rodan's running a Sweet 16 that me and Zane at Big Rig Radio built him. And it's got DEI transistors in it. And he hits it with an 80-watt striker. And he's been talking on it for 4 years, 2 trucks. Just saying. 2 different semis, 4 years, no problems. It's all about drive. It's all about how hot you let the amplifier get. And it's all about paying attention to your swirls. So, gentlemen, I apologize. I'm not super chipper today. I got nothing sarcastic to say about anything or anybody or anyone. Except for myself. I went shooting today and I didn't shoot for shit. I'm a little pissed off at myself about that. Oh, let me show you this. This is kind of cool. This is a hunk of plastic that I used to make my LTO lithium battery case out of. And this is a 45 round. It caught it. Like it completely caught it. This has got a bubble to it on the back side. But it turned around like inside out. It was really neat. And then the reason it shattered is because I shot it with a 308, which whistled right on through like it wasn't even there. The 9mm, it caught it. Shot it with a 308 over here and it shattered the thing. We shot it with a 9mm up here and it completely caught that. We even shot it over here with a high velocity 9mm super penetrator, blah, 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 blah. I was going to shoot video of this, but I had to sit there and think long and hard about it. If I do that and I show any kind of firearm operation other than the one I've already been doing, YouTube has a conniption fit. So it's just not worth it to me. But it is impact rated. I thought that was pretty neat. That was a 45 ACP ball round. Caught it very smoothly. 9mm round, it was amazing what it did to it. It spun it like inside out and flipped it around backwards by the time it came through the glass, and it stretched it way out. I mean, there's like a bubble like this. But that 308 round just shattered this piece of Lexan. Thought I'd share it with you. Well, gentlemen, I got to run. I I got a 10 pill I got to go work on for my buddy Richard. He's been waiting for me to finish my mobile so I could finish his box. Patiently waiting, might I mind, and add into the commentary. So now it's his time to burn in the sun just a little bit. Well, at least for the rest of today. Gentlemen, I appreciate you all. Big shout out to Siglent. Big shout out to Excess Power. Big shout out to MechMan. Big thanks to Bird and Coaxial Dynamics. Moving on to the next one. Yeah. I think I'm going to rework a 12 pill that I built that a guy decided to pull the transistors out of and change it over to 2879Cs because he thought he was going to get more power than his old school Toshibas. That's the next one I think that's going to come up. And then Richards, I think that's just the way it's going to work. So, on that note, Mr. R, I'm going to send you back all your DEIs. I don't want them. I have no need for them. I'm going to put them in a little baggie, and they are going to come home with your Texas Star. So, on that note, gentlemen, I'll see you. Thank you again for tuning in, checking it out. Please take a minute, hit the subscribe button. I'm always here doing cool shit just like this, although I lost my mojo on this video, I'm not going to lie. I'll see you guys. Bye-bye.